Chapter 11, Part 4. The doctor has ordered 750 milligrams of a drug to be given over 5 minutes. The concentration of the drug is 75 milligrams per milliliter. Okay. Find the total number of milliliters you will administer. Well, the order is 750 milligrams. I'm going to put this over 1. The drug concentration is 75 milligrams per milliliter. I'm going to try to get rid of milligrams, so I'm going to put the 75 in the bottom. And then I have 1 milliliter in the top. So milligrams cancel. If you divide this by 75, you get a 1. Divide this by 75 and you get 10. So we are going to give 10 milliliters of this drug. Okay? Now, determine the IVP flow rate if you divide the infusion into 5 equal segments. Okay? Flow rate is the volume over time. Okay? So my volume that I'm going to be given, we figured out right here, is 10 milliliters. And this is over 5 minutes. Okay? So this is the flow rate, okay? And I'm supposed to divide this into 5 equal segments. So what I'm going to do is I'm going to divide each of these by 5. And that will give me, because I'll have to break this up, which gives me 2 milliliters for every 1 minute. Okay? Now determine the IVP flow rate if you divide the infusion into 10 equal segments instead. Okay? Well, I start off here. I'm given 10 milliliters for every 5 minutes. Here I was breaking up into 5 equal segments. Here 10. I'm going to do basically the same thing. I'm going to divide each of these by a 10. So you're given 1 milliliter every 0.5 minutes. Or you could say 1 milliliter per 30 seconds. Okay. All right, so let's go on to example number 10. The order is 1,500 milligrams over 4 minutes. The 2-gram vial has a strength of 1 gram per 10 milliliters. Find the total number of milliliters you will administer. Okay, so the order was 1,500 milligrams. Okay, and the strength is 1 gram per 10 milliliters. Okay, this is in grams. I have milligrams here, so I need to convert from milligrams to grams. There are 1,000 milligrams in 1 gram. Okay, so the milligrams cancel out. And if I divide this by 100, let's get rid of these 2 zeros and these 2 zeros. So right now I have 15 over 10. All right, which would be, I'm supposed to give milliliters. So I'm just going to keep it like this for right now. And the strength is 1 gram for 10 milliliters. I'm trying to get rid of grams, so I'm going to put 1 gram here in the bottom, and I'm going to put 10 milliliters here in the top. Okay, the grams cancel, the 10s cancel, so I end up with simply 15 milliliters. Okay. Determine the number of milliliters you will push during each 30-second interval. Well, we're supposed to give it over 4 minutes, so how many 30-second intervals are there in there? Well, there are 2 30-second intervals in every minute, right? So if I multiply this by 2, I should have 8 intervals. Okay? So what I need to calculate is I'm supposed to give a total of 15 milliliters. I would divide this by 8. Okay, and if you divide 15 by 8, you get 1.875, which is approximately 1.9 milliliters every 30 seconds. Okay, now determine the number of seconds needed to deliver each 1 milliliter of the solution. Okay, I have 15 milliliters for every, I'm giving a total of 15 milliliters over 4 minutes, right? Okay, I need to convert to seconds. For each minute, there are 60 seconds. Okay, so I'm just going to try to do this in each. Okay, so I have 15 milliliters, and that's going to be 240 seconds. Okay, now what I can do if I want to find out how long it takes for each milliliter, okay, if I can divide this by 15 and also divide this by 15, okay, we can do this because it's the same value. This will give me 1 milliliter. We'll take 240, divide it by 15, and you get 16 seconds. So it will take 16 seconds to give 1 milliliter of each solution. Okay, number 11. The prescriber ordered 250 milliliters with 60 milligrams of a drug at 0.006 milligrams per kilogram per minute. The patient weighs 75 kilograms and the drop factor is 20 drops per milliliter. Calculate the flow rate of this drug in drops per minute. Okay, there's a lot going on here. So, I guess let's just start. I'm going to start off with the weight so I can simplify this thing. So we know this patient is 75 kilograms. I'm going to put this over 1. And then I have 0.006 milligrams per kilogram per minute. Okay, so the kilograms cancel out here. And when I multiply 75 times 0.006, I get 0.45 milligrams per minute. Okay, so I've used this and I've used this. Now let's work with the strength of the drug. Okay, it's 250 milliliters and there's 60 milligrams in there. I need to get rid of milligrams, so I'm going to put the 60 milligrams in the bottom, and I'm going to put the 250 milliliters in the top. Okay, now when I do that, the milligrams cancel. I can divide each of these by 10 and make my numbers a little bit better. Multiply across 0.45 times 25 is 11.25 milliliters per 6 minutes. And, I will, keep my decimals and not go through ugly division until the end, okay? So now I've used this and this as well. All I have left here are 20 drops per milliliter, okay? So I'm trying to get rid of milliliters, so I'm going to put the 1 milliliter in the bottom. And then there are 20 drops, okay? So the milliliters cancel. If I take 11.25 and then multiply that by 20, I get 225 drops per 6 minutes. So I'm going to divide this by 6 and see where I get. I get 37.5, which is approximately 38 drops per minute.